Tell me who fixed it? Who are please hide you. This requirement. I still know shit about cities. That's why people in other
Okay, good morning. If you could settle down, please. Okay, we'll get started. Today's session, I'm sure that many of you are going to ask me so many questions. And it's funny enough that every time I teach this session, I get asked, especially by the male students, can you make alcohol? I always get asked this. No, I don't make it. I know how to make it, but I don't make it. As simple as this. And I'm not telling anyone. And actually, a couple of students, they did it as a science project and they challenged me. And I said, no, I'm not giving you any hints. And they were able to make it. But beyond that, the reason we're going to discuss biochemistry of alcohol is sadly that even if you are a doctor here in a Muslim country, you will be treating alcohols. If I tell you that the Middle East is rated #1 in terms of alcohol consumption, I'm talking about the Arab countries, you'll be shocked. And the reason I'm saying this is sadly because of the fact that as a physician, you will be treating alcoholics. And you're going to come into an issue here. Did you report the person? Did you not report the person? But also, more importantly, hopefully, if you go to do your residency to another Western country, you can't believe the number of alcoholics you're going to be treating. So you need to learn about it so that at least you understand what's going on. Before I immigrated to US, I was born in Kuwait, and I remember we had maids, non-Muslim maids, and every few weeks they used to take them to the hospital intoxicated because they thought that they could drink cologne, perfumes. And what's the problem with cologne and perfumes? They have methanol. Methanol could damage the liver completely, wipe it out. So how do you treat someone who has methanol intoxication? What do you do with it? You give him alcohol, ethanol. But why? You'll see why. So you would give the ethanol as an antidote for the methanol. And we'll talk about the mechanism that could damage the liver and so on. So we'll have some aspects also. I'm sure that many of you are wondering, is there alcohol intolerance? Is there, why is it that Asian people usually, they drink small amount of alcohol, they flush, they end up with hangovers? What's the reason? So we'll talk about the genetics behind this. And also there's a lot of conceptions or misconceptions in terms, can we take antihistamine to prevent hangover? What is hangover in the first place? Well, hangover is the bad feeling you would get after getting drunk. That includes headache, vomiting, and nausea, and flushing, and all. This is what we call hangover. And the reason we end up with hangover is because of acetaldehyde. We're going to talk about the pathway for alcohol metabolism. 3 key enzymes, we'll discuss them, and that's a simple pathway. But we'll talk about what if, you know, if you watch the movies and you see someone who's alcoholic and they take him under the water and they just, you know, soak his head with water. Does this work? Does it work when you drink caffeine? Coffee, would that really get you awake? No, that's all wrong. So we'll talk about these things. Hopefully now I got your attention. Let's start talking about the biochemistry. These are the objectives of today's sessions, where we do expect you to know the metabolic products of ethanol metabolism, in particular acetyl-CoA. And we're going to say, okay, why acetyl-CoA? Because we could synthesize fatty acids, lipids. Have you heard about the beer's bellies? You drink too much beer. Here's my question, think about it, and maybe at the end of the lecture we'll ask. That alcohol, non-alcoholic beer that we have in the market here. First question, is it really 100% non-alcoholic? One. Two, would you gain weight similar to if it was alcoholic beer after what you're going to see today? So we'll answer these questions at the end of today's session. Also, we'll talk about the metabolic effects, clinical significance of ethanol and its metabolites. Now, alcohol, when we say alcohol, that includes beer, wine, and other alcoholic beverages. And we'll talk about some of them so that you know when I say a glass, what do we mean? Because we can calculate how long it would take you to get drunk. Simple as this. So we'll see why is it that if you notice that when people, I'm not advocating drinking, I'm just telling you reality, okay? I just want to make sure that I never drank, except maybe once. I have to admit that without me knowing, I went to a journal club and they had open bar that was in Buffalo, New York. And I asked for virgin daiquiri, which means non-alcoholic. And they made a mistake and they served me alcoholic daiquiri. And I have zero tolerance. I don't remember anything from that day, okay? And I asked my colleagues, was I dancing on the table? They said, you were bad, but not to that extent. So I have zero tolerance because if you never had drink, the question is that, can you build tolerance? No, you can't. I'm going to show you, provide you evidence with this. Initially, yes, maybe 1 glass, 2 glasses, but then as you get into drinking, you'll see that alcoholic cannot tolerate alcohol. And we'll talk about why, which enzyme is involved with that as well. Okay? So, what is alcohol itself? Well, when we say alcohol, it does not include any nutrient value, no vitamins, no nutrient value, and it is high in terms of energy, 7 kilocalories per gram. It's either kilocalories or large C, which is kilocalorie. That's how we look at it. So it's 7 kilocalories. This is why you see that in cold weather, especially in Russia, in the cold weather, they're always drinking vodka, right? Why? Because it provides a lot of heat for them. This is why, because of the fact that it has 7 kilocalories. How much do we get out of proteins and out of carbohydrates? 4. And fat, lipids, we get 9. So this is 7. And this is basically nothing other than, I'm talking about alcohol, but when we're talking about beer, wine, there are other ingredients other than alcohol in these beverages. Could have proteins, could have carbohydrates, so that's more calories. So even if it's non-alcoholic, you're still gaining weight because you're drinking carb and proteins at the same time. So we have to differentiate between alcohol that's in the beer, wine, and so on, and the beer itself and other ingredients, okay? So what's the difference between fermentation and anaerobic respiration? Anaerobic, the end product is lactate. Fermentation, the end product is ethanol. So that usually happens in the yeast, but there are other organisms that could ferment the glucose as well. So the end product is CO2 and ethanol. And here's the thing. If you look into these big barrels, I'm sure that you've seen the movies, why is it that some of these, they would throw them away because they say they went bad? The yeast cannot survive after the ethanol concentration reaches 10%, 10 to 15%. So if these barrels, the yeast was able to grow, it goes bad, they throw them away. And usually they stop it before the yeast, the ethanol becomes 10 to 15%. So that's a hint in case you are interested. Okay, where do we absorb ethanol? It starts in the mouth, minor. But the majority is in the small intestine. And we're talking about 75 to 80% of ethanol is absorbed in the intestine. This is extremely rapid. And usually ethanol is absorbed intact by simple diffusion. In the stomach, we have 20 to 25%. Why do I need to know this? Because of the fact that when ethanol is absorbed intact, it's into circulation, it reaches your brain, gives you that buzz, gives you that effect on the nervous system. If it gets metabolized, then it lowers the alcohol level, the ethanol level, so you don't get that effect. So when we say someone is tolerant to alcohol because he can metabolize alcohol at fast rate. As a matter of fact, my boss, Dr. Paresh Dandona, he was originally from India, lived all his life in the UK. His kid, I've never seen anything like this in my life. I mean, he used to invite us to his house and he would have vodka, tequila, everything mixed, and then a couple of drops of orange juice, and he would finish it himself, my boss, by himself. And then he has such a high tolerance. I've never seen anything. So would that be genetics? His kid, who got accepted into McGill in UK, the College of Medicine became #1 in drinking competition when he joined College of Medicine. The guy would finish anything and no effect. And his dad is like his dad, so it's genetics. He has such a high tolerance, and the whole thing comes from the fact he could metabolize alcohol pretty quick, so he won't get drunk. As simple as this. The worst thing happens with the Asian. They metabolize it fast to produce acetaldehyde, which causes the hangover. But the problem, acetaldehyde cannot be metabolized because they have a problem with the next enzyme that would metabolize acetaldehyde. So they end up with a lot of acetaldehyde. They end up with hangover just pretty quick within the small drink. They would have hangover, flushing, and redness, and so on. So we'll talk about this because we'll see about the effect of age, the effect of other. Why is it that female, for instance, also they end up with hangover with small drinks? Because the fact that their metabolism is not as fast as the male. So the males could drink more than the females. The body weight would affect as well the metabolism of alcohol. The faster you metabolize, the better you get rid of it. Otherwise, you end up with being drunk. So, is it only through the gas, the stomach and the intestine absorption? This is what is called alcohol without liquid. And they would inhale the alcohol. It's fast buzz, and the reason they're saying this because there is no metabolism that occurs in the first pass metabolism or second pass metabolism that occurs in the intestine or the stomach. Why? Because then they don't have hangover. They don't produce acetaldehyde. This has been illegalized since the 80s, I believe. It has been illegalized because that's really straight shot of alcohol into the brain, as simple as this. And they ended up with many deaths, especially if it's mixed with drugs. Have you ever wondered why is that alcohol and drugs, you always end up with overdose of drugs, even though he's taking the same dose of whatever ecstasy or whatever dose is taken of drugs. And then when he takes alcohol, he ends up over OD. That's one thing. Not only this, you're maintaining certain medication for a patient, whatever condition. And then that patient starts drinking. You'll see that you have to adjust the dose as well. Why? What does ethanol do to the drug metabolism? We will discuss that as well. It's funny, when I was my housemate, when I was in New York, he used to do this all the time. I didn't know that time, I was still undergrad, but it is common until now, actually. And it is scary. They used to have these bars just for taking this alcohol where it gets nebulized with oxygen, and they would inhale. So the alcohol would get into the circulation without metabolism. They would get the buzz. They don't have the hangover because of acetaldehyde formation. So alcohol will be distributed in the body water, not in the body fat. 90% is usually broken by the liver. So the liver has the function of detoxification of the alcohol. 10% that would be eliminated in urine, sweat, expired air. This is why we have the breath testing machine that will test ethanol in the breath. Here's the question, just in case you are going to US to know your protection. If someone gets caught driving while intoxicated, DUI, driving under influence, can the police officer force you to take a blood sample? Because this breath test, by the way, does not stand any legal stands in the court, even if they find that you have high alcohol in your breath. The only legal test that would stand is blood levels, BAC, blood alcohol concentrations. Can they force you to take blood sample? No, because you want to incriminate yourself and you have the right. But the problem, you're drunk, so you don't know what the hell they're doing anyway, right? So this is one thing about the level. Even though it's in sweat, the expired air, it doesn't have any legal stances in terms of being used in the court. And as indicated, it represents empty calories. Why? Because we're going to see what is called me-first metabolism, where this alcohol gets metabolized first before the fatty acids and other metabolites. As a result, you would gain more weight if you're drinking a lot of alcohol. Okay? And I gave you that. If you, for instance, if someone takes 473 ml of 80 proof, 40%, we're going to look into what's the difference, because then you would say, at least you have to know when we say glass, what does it mean? How much is it in terms of alcohol percentage? So 80 proof, 40%. We're talking about here similar to tequila, vodka, high concentrated alcohol. We'll see the beer, wine, and so on. What's the percentage? As I said, I know I'm talking about doctors. You have to know the language because you will be talking to these people. As simple as this, you will be treating alcoholics and so on. So you need to learn the language. It's not that we're here just to have fun. It's just you need to know this because this would help you when you discuss with him how many glasses do you drink, how many, the whole effect and so on. So at least you would understand what he's talking about. So at least if you're taking 473 ml, that's basically enough calories for the whole day. So imagine when someone finishes a full bottle. Now, the other thing also I forgot to mention, why is it that if you notice that people who are drinking in these movies, they're always eating something? Nuts and so on, why? Because this would slow down the alcohol, basically absorption, and the stomach basically release of the alcohol into the intestine. So this way you don't get drunk fast. And you'll see the speed of drinking basically will affect whether you're going to get drunk or not. So when you see them eating, they're trying to slow down the absorption. The reason I brought this issue because I said it starts in the mouth, but it starts 25% in the stomach and then into the intestine. So when you slow down the emptying of the stomach, you're slowing down the absorption because it's faster in the intestine. As simple as this. We do have what's called first pass metabolism and second pass metabolism. The first pass metabolism occurs in the stomach. Okay? And the second pass metabolism occurs in the liver. There are two enzymes I want you to know. The first one is the ADH, alcohol dehydrogenase. The second one is ALDH, which is acetaldehyde dehydrogenase. These are the two key enzymes. It's really a simple pathway, and everyone should get the questions, 3 or 4 questions, MCQ, without even thinking, because there's not that many pathways that you're going to think about. So we have the ADH, alcohol dehydrogenase, acetaldehyde dehydrogenase, sometimes it's called aldehyde dehydrogenase. It doesn't mean the same name, acetaldehyde or aldehyde dehydrogenase. Okay, and then the term BAC, blood alcohol concentration levels. What's the legal blood alcohol concentration right now in US? Here, of course, 0, even 0.01 will be illegal in the Middle East and so on. But I'm talking about Western society. What's the blood alcohol concentration? 0.1%. And 0.1%, by the way, even if you're taking USMLE, you will get questions about alcohol because that's part of their lives and you will get many of these questions. So we need to learn about it. So the blood alcohol concentration is 0.1%, and there are some states, around 3 states, that made it 0.08, which means if your blood alcohol concentration is 0.1% of your circulation percentage, or the ratio of ethanol to the circulation volume is more than 0.1, this is DUI, driving under influence, in case you're driving. And basically, that's when they say you're wasted. This is what they call being drunk. So, but here's the thing. There are 3 pathways for ethanol degradation. The first pathway is the ADH, which we said is alcohol dehydrogenase pathway. Notice here we have Michaelis-Menten constant. We're going to have enzymatology next semester. We'll come back to Michaelis-Menten constant. And Michaelis-Menten constant basically is the substrate concentration that will give you 50% of the enzyme activity. So how much substrate you would have to get 50% of the enzyme activity? So the KM for this one is 2 millimolar. We have another system, which is the microsomal ethanol oxidizing system, MIAS. And this is the system involved in terms of detoxification of many of the drugs that hopefully you will be prescribing for patients. And also detoxification of drugs, whatever drugs it is. So here we're talking about ethanol competing with drugs, right? So, but the CAM is 10 millimolar, which means you need to have high concentration of ethanol, higher level of ethanol to get the MIAS to kick on. The primary system is the ADH pathway. And in order for you to get MIAS to kick on, you need almost 5 times the concentration needed for the ADH, which means if you're taking small amount of alcohol, no problem. But if you're taking large amount of alcohol, that's when the problem is, because then the MIAS is busy, occupied with alcohol metabolism, not metabolizing the drugs that the patient is taking, or if it's taking illegal drugs and so on. So this is why they end up with OD. So this is why, in case someone is drinking heavily, then you're going to have a problem in terms of balancing his medication. Or if he's taking illegal drugs, then he can end up with OD. Simple. Okay? Now, the last system, which is around 2 to 3%, is the catalase, which also detoxifies ethanol, but it's not that main enzyme. So we're talking about MIAS accounting for 15% of processing in heavy drinkers. Notice here I said heavy, because usually it doesn't kick on until they start drinking heavily. So the pathway, the first one, we have ethanol gets into the liver. ADH, alcohol dehydrogenase, would produce acetaldehyde. We said, what did we say about acetaldehyde? It's responsible for the hangover. Now, acetaldehyde gets converted to acetate by the ALDH, acetaldehyde dehydrogenase. Really straightforward pathway. Acetate now is pumped into circulation and can be utilized in the muscles for energy production by acetate synthase. So we have, the acetyl-CoA synthetase, ACS, to produce acetyl-CoA, and this would get into circulation. Simple pathway. Now, it looks heavy. You know all these pathways except the fat pathway because we haven't studied lipids, but I'll make it simple for you. Why is it, now we're going to talk as doctors, why is it that alcoholic, do you think that they would have hyperglycemia or hypoglycemia? Hypoglycemia. Hypo, they're loading with calories. Why? We're going to discuss this as well. Why they would have lactoacidosis? Why would they have ketoacidosis? Why would they gain weight? Does really these calories taking as ethanol, does it really get saved in the fat as triglyceride and so on? So this pathway answers these questions. Let's start with the first pathway that you already know. Carbohydrate, glucose 6-phosphate. We have pyruvic acid, acetyl-CoA, citric acid. Notice here we said no gluconeogenesis. Why? So glucose 6-phosphate is not being converted to glucose. As a result, heavy drinkers, as a matter of fact, they have hypoglycemia. And usually when they drink heavily, they come to you, you give them sugar because they're hypoglycemic. Why? Here's a slide that will explain it to you. Alcoholic hypoglycemia. So we have ethanol right there being converted into acetaldehyde, acetate, right? Notice here we have NADH production. This is key because that NADH will cause most of these symptoms with alcoholics. We have NADH from acetaldehyde acetate. Because why? Because it's dehydrogenase. So we have alcohol, dehydrogenase. And then we have the next one. NAD is being actually converted to NADH by acetaldehyde dehydrogenase. Look into the intermediate in gluconeogenesis. We have pyruvate. Pyruvate in anaerobic respiration gets converted to lactate, right? And it utilizes NADH. So if you're producing too much NADH, this will drive pyruvate to lactate. This is why they have lactoacidosis. NADH produced from alcohol metabolism will drive the conversion of pyruvate to lactate, period. So you have lactoacidosis. But what happens to the pyruvate? It goes down. And we know that pyruvate is needed for gluconeogenesis. At the same time, pyruvate can be also converted to oxaloacetate, which also can be converted to malate in the presence of high concentration of NADH. So what happens with oxaloacetate? It goes down. As a result, low pyruvate, low oxaloacetate, what happens? So this will lead to inhibition of gluconeogenesis. And usually these heavy drinkers are, in terms of diet, they're not cautious about their diet, so they end up with hypoglycemia. So now we just explained why we have lactoacidosis, why we have hypoglycemia. Okay, you have too much NADH being produced. That NADH will drive pyruvate to lactate because it's a substrate. So that will push this reaction from pyruvate to lactate. So you have high lactate levels, that's lactoacidosis. Does it make sense? So let's go back to our figure. So now we know why we have hypoglycemia. The other thing also, what about, we talked about the pyruvic acid, gluconeogenesis being blocked. What about the ketoacidosis? What happens with ketoacidosis? Well, let's look into the NADH being produced through conversion of ethanol to acetaldehyde and then acetaldehyde to acetate. We have a lot of NADH being produced. The first thing it's going to do, as we indicated, it will push pyruvic acid to lactic acid, lactoacidosis. Second thing, me-first metabolism, meaning this is ready-made NADH. So why do we need to mobilize more fatty acids to produce energy? Because we already have the NADH as a source of energy, right? So this is what we call me-first. So that's why people who are drinking alcohol, they gain weight because they're not burning fat. And they're utilizing the ethanol as a source of energy. So that's why it's straight directly into the electron transport chain to produce energy. Thirdly, fat metabolism. We're going to have lipogenesis and lipolysis next semester. If I tell you that only 3% of ethanol would contribute into fatty acid synthesis, would you believe that? So the ethanol will not be converted to fatty acid. All what it's doing, it's sparing the fatty acid oxidation, beta oxidation. As simple as this. So what happens is that you would have, to some extent, 3% of ethanol will be utilized to synthesize glycerol and fatty acids. It's almost minimal. Some people even debate that percentage. And then we have the lipogenesis, because of the fact that we have acetyl-CoA accumulation. Where do we get acetyl-CoA? I told you the enzyme, acetyl-CoA synthase in the muscles, right? So this would convert the acetate to acetyl-CoA. So you have higher acetyl-CoA accumulation. When you have high acetyl-CoA, that's the precursor for ketone bodies. So you have ketoacidosis. Does it make sense? This diagram sums it up, basically, all the reactions that you need to know for alcohol metabolism. Let's see if we could elaborate more. We already talked about this, talked about this. Talked about this. So how does it happen? What happens basically in terms of toxic effect associated with hepatic enzyme, which is the MEOS, cytochrome P450 2E1, or what we call CYP2E1. This is the same name as the MEOS. Okay, so you have acetaldehyde, you have ethanol, you have NADPH with oxygen. All this would produce free radicals. We have a full lecture. Your last lecture is going to be about free radicals next week. Of course, of mole 114. Next semester is going to be mole 125. So we're going to talk about all these free radicals, superoxide, hydrogen peroxide, and their mechanisms next week. But they are produced. If I tell you, not a single process in your body occurs without free radicals involvement, as simple as this. Everything would involve free radicals, and we'll discuss this in more detail next week. As a process, as pathophysiological process. So, in terms of ethanol excretion, we're going to talk about 10% being basically excreted through urine and sweat and breath as well in unchanged form. And we talked about the breathalyzers by a lung measurements. Presumptive level of intoxication, most of the states, for instance, in the US, it's 0.1%. And this is basically the ratio of alcohol in the blood to the total volume of blood expressed as a percent. Right now, some states are lowering it to 0.08 because they say that's too much to reach 0.1%. Here's an interesting, after all, biochemistry is not boring, so we'll discuss why it's not boring. If you know this fact, for 160 pound, 72.6 kilogram individual, each drink would increase basically your blood level by 0.02%. At the same time, per hour. At the same time, 0.02% will be metabolized by your body every hour. So if you're drinking one drink every hour, that BEC will be, after 1 hour, 0. That's why people, when they drink, if you notice, they're drinking slowly. So they're allowing the metabolism of alcohol to occur so that they don't get drunk. They don't elevate their level. And this is how people, if you notice, they know what's their concentration because they are conscious about how much they're drinking per how many hours. But imagine, I've been to these nightclubs where they have the tequila shots. Everyone is tequila, tequila, tequila. They bring them these small shots of 80 proof drink, and they would take 4 or 5. They're wasted right away because each drink basically would increase 0.02. So they already reached it by taking just 5 drinks right away. They reached the BEC. By the way, tequila, everyone told me that this is only Mexican actually who make it, and it tastes like pee because it's for poor Mexicans. And yet in the Western society, they say, oh, it is something, interesting, exciting, and only poor people in Mexico would drink the tequila, simple as this. Anyway, I'm saying these things because you will hear about it. Even here, if you treat patients, you have to know what does he drink. You have to see how you can treat that patient. As simple as this. So when I say drink, what do I mean by drink? Let's answer this question. Individual weighing 160 pounds consumes 2 drinks per hour. What will be his or her back level blood alcohol concentration at the end of that time? Let's talk about what is meant by a drink. So it depends on the type of beverage because it has different alcohol concentration. So if you're looking into beer, we're talking about 5% alcohol. If you're talking about malt liquor, we're talking about 7%. If you're talking about wine, 12%. If you're talking about 80 proof spirits, we're talking about almost 40%. So the volume, I gave you the volume here to see how basically they usually figure out that when you go for table wine, if you notice that they pour of small amount, that they try to get it to 150 ml. Now you know why how much to pour into the glass. Okay, because they are counting how many glasses they would drink so they don't get basically beyond the blood alcohol concentration back of 0.1% because they could be basically held for DUI. So this is how people are conscious about how much so that they know how much they're drinking, as simple as this. So let's go back to our problem. So you have the first hour. We said first hour, drinking 2 drinks. So we have 0.02 plus 0.02% of BAC. But he or she metabolizing 0.02%. So the total is 0.02% at the end of the first hour. Let's go to the second hour. I'm not going to ask you in the exam how many drinks, and this is for your information. Okay? And unfortunately, if you go for your residency in US, you may have to advise some people because you know that they're alcoholic and they cannot stop drinking. So at least you need to tell them how much to drink initially until they cut down their drinking. That's why I'm giving you this information. You're not going to be asked about it, as simple as this. So the second hour, 0.02, 0.02, 2 drinks. But we're metabolizing 0.02. But you already have 0.02 from the first hour. So you end up with 0.04%. And it will take you 5 hours to reach 0.1% driving under influence. Simple, right? Okay. So what are the factors that affect or inhibit ADH activity? Do you want to metabolize alcohol? I'm talking about people who are drinking. Do they want to metabolize alcohol? Yes, they don't want to get drunk. Because if alcohol is not metabolized, it gets into circulation, affects the nervous system. Simple. So, antihistamine drugs. Some people, because they don't want the hangover, they take the antihistamine. Why? Because they said we don't want acetaldehyde, because acetaldehyde being produced from the ADH, by the ADH, will cause the hangover. Believe me, I've seen my friends, when I call them, why aren't you at work? They say, well, we have hangover, we were partying yesterday, and they spend the whole day wasted. They're throwing up, flush. I mean, you don't want to see them. They're really in miserable shape. So they don't want that effect. Some people take antihistamine. And what exactly antihistamine? What does it do? It allows you to get drunk faster. Yes, it could reduce the hangover, but it gets you drunk faster. So it's not worth taking antihistamine. What about alcoholics? If I tell you that ADH is decreased with people becoming alcoholic, they drink heavily. So what does this mean? They become drunk faster because it's not being metabolized. So when they become heavy drinkers, alcoholic, they would get drunk faster than someone who's not drinking and they just occasionally drink. So this is why when we say, can you build tolerance? Well, aging would decrease ADH. So what does it mean? As you get older, you become drunk faster. Ethnicity. Here's the problem with the ethnic people. I mean, I used to go to China and Taiwan almost once a month. So they would drink small amounts in the restaurants, and eventually, I mean, just small amount, they already wiped out. Why? Simple, because of the fact that they are able to oxidize alcohol at rate 20% greater than normal people, genetic. So ADH is more active. Okay, you're metabolizing it. The problem is the ALDH is slower by 50%. 50% of Asians have inactive ALDH. So they have what? Acetaldehyde. So they have hangover pretty quick, flushing, headache, and so on. And this should actually, would this force them? Do you see more alcoholics in China than in the Western society? What do you think? Because people don't want hangover, so they don't drink that much, right? And this is what we're going to talk about, the alcohol treatment. Treatment for alcoholics is to make that alcoholic feel what? Hangover. How? By blocking which enzyme, ADH or ALDH? ALDH, block it, give him acetaldehyde, he gets the hangover. It's not a pleasant feeling, so they would stop drinking. Does it make sense? Okay. So lean body mass, of course, lean people would get higher body fat can affect rate of metabolism. What do you think? Being overweight, would that affect in terms of metabolism faster or slower? What do you think? Well, it's either faster or slower. So which one you would pick? I'll leave you with that question. At least I should leave you one question, right? I know some people are going to come and ask it, but think about it. Dietary factors, people are eating or not eating. So are there genes involved with alcoholism? This is for your information. Usually enzymes involved in alcohol metabolism, if there is polymorphism in them, and I gave you examples in Asia, then this would affect whether people are going to develop alcoholism or not. And when we say alcoholism, it's not about just drinking, being dependent on alcohol. This is alcoholism, okay? So ALDH involves in metabolism, has been shown that there is relation in terms of alcoholism and ALDH. We have the alcohol ADH as well. We have the GABRA, and there are many. I used to teach this actually as a full lecture in the National Guard before moving here about genes, genetics, and alcoholism. I don't think there's a need. Just know that most of these enzymes involved in alcohol metabolism are related to alcoholism. Okay, and ALDH is an example. I'm going to give you an example where basically Asians with certain genotype show extensive flushing, as I said, to low doses of alcohol. So they were found to have higher plasma levels of acetaldehyde. As I indicated, this basically is probably related to a deficiency of an isoenzyme in the ALDH. To be more specific, we have polymorphism. You know what's polymorphism, right? Why? I mean, we all have different DNA, right? Because of what? Polymorphism. Each one has different gene. And this is as a result of different mutations, mostly in the introns and so on. This is why we have polymorphism. So we have ALDH2, 1, ALDH2, 2. This is high activity, this is low activity. Which one you would expect to be higher in Asian? They have high acetaldehyde. 2, because we said acetaldehyde is building up, it's giving them hangover, right? This is just comparison of the two. Of course, we know the harmful effect of the alcohol. I'll leave that to you to read because you're taking GIT, so we'll talk about the liver cirrhosis and how it could induce liver cirrhosis. Now, chronic metabolic effects of alcohol. We already discussed this. Let's try to review it. What happens to the blood levels? Fasting hypoglycemia. Why? Because gluconeogenesis is blocked. Diversion of intermediates because of increased level of NADH, right? What about clotting time? Liver synthetic capacity is impaired because of liver, because we have cirrhosis and so on. As a result, we have low synthesis of clotting factors. We have edema. Why? Because the liver synthesizes albumin and the liver function is impaired. So albumin synthetic capacity is impaired. As a result, we have albumin going down. We have hyperammonemia because of there's increased urea cycle. Fatigue, this is bad breath, alcohol intolerance, and jaundice. Moreover, alcohol is a teratogen, and this could induce fetal alcohol syndrome or fetal alcohol effects, and these are the symptoms of an infant with fetal alcohol syndrome. This is why they always advise pregnant women do not drink. And hopefully once you do your residency, you'll see a lot of pregnant women drinking, and this is one of the reasons that they are advised not to drink. But also, they have thiamine deficiency because drinking alcohol affects vitamin B1, thiamine absorption. So this is why we have thiamine deficiency, and chronic thiamine deficiency would lead to more severe neurological symptoms, ataxia, mental confusion, loss of eye coordination resulting in nystagmus, but also could affect cardiovascular and musculature as well. This is vitamin B1 deficiency. And this is because of the fact that absorption is affected. We have the Wernicke-Korsakoff syndrome. It's actually two conditions in one. Because of the fact that we have vitamin B1 deficiency, thiamine deficiency, this results in two combined syndrome manifestation of Wernicke's encephalopathy. At the same time, the Korsakoff psychosis, which main symptom is amnesia. Alcoholic myopathy, believe it or not, drinking alcohol could lead to myopathy. And 1/3 of the heavy long-term alcohol consumption, basically, both genders races, develops skeletal myopathy, and the acute form is in the form 4 times more common in males than females. So heavy drinkers, you might have myopathy. Why am I saying this? Because as I said, you could tell if someone is drinking or not just from his symptoms and so on. And actually, the question is that would you report that person? If you're treating someone here in a hospital and you know that he's drinking, would you report him as a physician? You can't. You can't report him. You could advise him, send him for treatment, rehab, and so on, but you can't report him because he's drinking. The last thing, actually, the ethanol as antidote, and here we're talking about 2 things. Methanol, we talked about methanol because it damages the liver. Give him ethanol so that it protects the liver. The liver is not converting the methanol into formaldehyde and formic acid, which is very toxic to the liver. So when you give ethanol, it competes with methanol and MEOS. As a result, we're protecting the liver. But what about ethylene glycol? We used to have a lot of cases of children poisoned with ethylene glycol. What the hell is ethylene glycol? Ethylene glycol is antifreeze. It's that bluey green stuff you find as antifreeze. And most Western society, I used to have ethylene glycol in my garage because you have to add it to your radiator, especially during cold weather. My first car, I was so excited about it, but I came from Kuwait. I mean, I lived in Kuwait, and I didn't know that I had to add antifreeze into my radiator. So the first storm, the whole thing was frozen. Ethylene glycol is attractive to the kids. When they see it glowing, you should see, I mean, the antifreeze. It's sold everywhere. They would drink it. So to protect their livers, you give them ethanol. As simple as this. The last thing, treatment for anti-abuse, disulfiram. We said, what does it do? You need to block acetaldehyde dehydrogenase. Why? Let them feel bad. It's not enjoyable experience. So this is why they would stop drinking. Okay, with that I conclude. I'll take that attendance and then I'll take your questions if you want. So let me know when you're ready. If you're having a problem, please come to the stage. Again, I will not entertain requests about attendance. Make sure before you leave that you are marked being present.
المفروض طبعا stop recording.